Boom, she's back. Sweet. Okay. So that's what we're looking to do, right? This process. And so intuitively, what I'm thinking with this process, if I'm given a number, that's my starting number, either I can start at 1 and work up to that number, or I can start at that number and just take a number away, right? Decrease that number by 1 until I'm left with either the value of 1 or I'm left with 0, right? So there's 2 ways to kind of approach this factorial, up or down. So I'm going to start where maybe we go down in the factorial. So I'm going to decrement that number. So let's do, I'm going to say factorial, right? That's what we're going to be working on. I'm going to create a function factorial, and that factorial is going to take in a number, right? Well, I'm also going to do this. Once again, I'm going to change the behavior so we don't get these errors here happening. I'm just going to go behavior, auto update, save it. I did push up the code. I put it into a JavaScript file, push that up along with the link to the CodePen. So if you ever want to go back, I'll share the CodePen. I just think sometimes doing these little one-offs and with the CodePens might, you have access to the pen now. As I actually make changes to the CodePen, you would be able to just refresh your page and see those changes. So sometimes it's just quicker if you got lost to be like, boom, I'm right where I need to be. I just take a look and I can see exactly where Joe's at. So I'm going to do factorial. And we know, once again, if we call factorial down here, we'd have to do factorial, and we'd have to give it a number. That's the foundation of our logic right here, is that. Okay. So if we're doing that, we need some sort of, I'm just going to stop this right now. We won't call it right now. We need some sort of base case, and recursive case. Okay, so let's see. Iris is sitting in the dark and the ominous, like Cody was earlier. Iris, what's the base case? What do we use conceptually? What is the base case meant to do?
I don't know. I didn't get it the first time.
All right. Did I ask you earlier? That's well.
No, but even the first time I was like, oh God, I hope he doesn't call on me because I'm going to have to admit I know nothing.
You know what? That's fine. Like if I sit here and just expect everyone's like, oh yeah, I said base case 3 or 4 times, everyone knows what it is. And then when I ask, people are like, I still don't know what it is. This is the clarity that I need. So I know Shashira wants to tell me what it is, right? She wants to say what the base case is. She's dying to say
it. Where we want to end up.
Okay, I'll take that. Take a look at this. What does that say for base case? Can you see that?
You want me to read it? Okay.
Yeah, just read it.
The base case, when this condition is true, the function stops calling itself.
Okay. So the base case ends the function. Really, it stops the function. Okay, so base case is meant to end the function. It's our stopping mechanism. It's the condition in a for loop, right? So I is equal to 0. If I is less than something, keep doing this. But if it's not less than something, then we stop. So it's meant to end the function. It's the condition that stops the function, right? That's really,
like something that keeps it from being like an infinite loop.
Correct. Yes, a base case is meant to prevent the infinite loop thing, right? Because if in the recursive case, if I had right here, I mean, we have factorial. If I said, hey, factorial, if I just did this, factorial, and I just ran this thing, well, let's walk through the process. If I called it here and I passed in the number 5, there's really no other code that's there. So factorial is just like, oh, I misspelled it. Factorial is going to be like, all right, I just got to run. Boom, I run again. I don't pass anything in. I don't really need to. Oh, look, I got to run again. I got to run again. I got to run again. The thing just keeps going forever. When do we stop this thing from running, right? So, you know, if we were to kind of convert this into maybe an if statement, I'm sorry, like a for loop, if we wanted to do something similar to that, right? We could say let, I don't know, I is equal to 0. And then in here, we could play a game like, you know, if I is equal to 3, then we could just return, right? We could just actually just return here. Otherwise, let's just do factorial. And factorial will console log. So maybe I'll try this. Just go console. I'll put that in between, right? In between the base case and the recursive case is kind of some logic that we want to run. Console log. I is I. Okay. And then we also have to increment I. So if I is that, do that. Console log I is that, and then I plus equals 1. Run the function again, keep running the function, and let's just see what happened if we were to do this. Okay. Factorial. I'm going to save it. I'm going to run it. Okay. So the function stops. The function stops when I is equal to 3. We return, and the function does not do anything anymore. Okay. If I set this to be 10, the function would run 10 times, but we still have a stopping mechanism, right? It ran 10 times, and then that was our stopping mechanism. If I don't do that, if I remove this statement here, this thing will break. It will go into an infinite loop, and it'll just keep going. We'll get an error message, actually. So I'm just going to copy this just in case I have to cut and paste it. But if I did comment this out and ran this thing, right? Look, that's infinite. At some point in time, it's just going to be like, you want me to stop, right? I mean, it's just going to keep going. There's no stopping. And then, yeah, here we go. CodePen is like maximum call stack size exceeded. You saw the call stack earlier, right? The call stack with these variables that were being added, right? I wonder if the call stack has anything. I'm going to do this one more time. I just want to take a look at the call stack and see if the call stack itself, yeah, doesn't look like the call stack's, maybe it's just happening so fast it's not adding it here. I'm not really sure. Yeah, I don't see anything happening here, but it's going to stop. We reached it. It's too many times. So it looks like at 5,845 times, it's like, dude, that's, I don't know what you're trying to do, but you're just using up too much memory at this point in time, throwing variables up there 5,000 times. So we don't want to do this. So we need a stopping mechanism. That's our stopping mechanism. Base case is our conditional logic of what happens inside of a for loop, okay, or a while loop where it says to do this. So we know that we need a base case for this, right? Well, just think, I said we're going to pass in the number 5, and the number is going to be times itself. What we're looking to do is do this. We're going to look to do 1 times 2 times 3 times 4 times 5. That's ultimately what we want to do, okay? Something similar to that, where we want to times ourselves by that number, okay? So, or we could reverse it too, right? Once again, it could be 5 times 4 times 3 times 2 times 1, right? Could be that as well, okay? So if we know that, then we know that at some point in time, we need to decrease 5 by at least 1. The sum that's passed back in, this number here, needs to be decremented by at least 1. But let's first work through our base case. Ultimately, say we are going to decrement by 1. What becomes our base case? I mean, this factorial here begins at the number 1. This factorial, the design, the approach, ends at the number 1. So if I had to say, hey, factorial function, recursive function, you should stop when? When do you think we should stop?
0 equals 0.
Okay, so we could do equal 0 or 1, right? I mean, if we return 1, if the last function returns 1, then it'll be 1 times 2 times 3 times 4 times 5, right? The function needs to return something, okay? So let's just say in this instance, I'm not going to say if I is equal to this, right? I'm just going to comment that out just so that you kind of have that concept of what we were doing. I'm going to say this. I'm going to have a if conditional statement. I'm going to say if number is equal to 1, I want you to do something, right? So I'm going to get rid of this I++. We don't need that anymore, right? And then I'm going to have an else statement in here, okay? Else do this other thing, okay? So if I is equal to num, I want you to return, what should we return? If number is finally down to the number 1, and we wanted to start multiplying 1 times 2 times 3 times 4 times 5, what should we return here?
Is it another function to get the next number?
Well, the else is, remember, the base case is how we stop, okay? The recursive case is going to be where we do our, and I'm going to put the recursive case in here, because this is going to be our recursive case. It's going to run inside the else statement, okay? So our base case, let's get rid of this, we're good, is this, is the if statement, and our else statement will be the recursive case, right? And recursive means that call the function again, right? Func, okay? So base case stops, recursive is the loop, right? Recursive case is the looping construct. Loop, 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 keep doing this, keep doing this, keep doing this, keep doing this. So,
Joe?
yeah.
Oh, sorry. Would you want to return like another variable that's storing the factorial result?
Okay.
So you could create another variable and then set it equal to something and then return that when it equals 1.
Okay, so I like that, right? So your logic is, and you mentioned return 1, right? Ultimately, if we know we're decrementing the number 5, and when the number is finally 1, we want the function to stop. We want the function to return. I'm just going to get rid of this. We want the function to return the number 1 so that we can start doing the multiplication. Because remember, every time the function runs, it's going to like load the number 5 into memory. It's going to load the number 4 into memory. It's going to load 3. It's going to load 2. It's going to return 1 and then start doing the multiplication. 1 times 2, 2 times 3, right? So I'm going to say here, we could return either sum, because sum at that point in time would be the number 1, right? Oh, I'm sorry, num. We could return num here, or we could just return the number 1. Either one will work. Because obviously, if num is equal to 1, then I can return num, but I can also return the number 1, right? So I'm going to just leave it as 1 just to make it as visually clear as possible. So now we know that this terminates the function, and this if statement is really this block right here. It's going to be this function call right here, okay? In the call stack, this 1 represents this right here, okay? So now we have to handle the other 4 iterations, which are going to happen here, right? So in here, 1 times 2, that's going to return something, right? So that, whatever that's going to be, right, that'll be 2, and then that'll be 2 times 3 times 4 times 5, and the sum of these two would be 6 times 4 times 5, right? And then 24 times 5. Right? And then 120. That would be multiplying these together. So if I know that this is the pattern, that 1 times 2 is going to get multiplied first, the result of that, right, will then be times by the next number, and so on and so on. In this factorial right here, this is what I'm going to do. I'm going to return something because I need to get something out into the memory space so that these values are accessible. I'm going to return number, okay? Because number is a number. We're going to pass something in here. And then what we're going to do is times it by factorial num minus 1. Okay?
This
So
is
by
the quadratic thing that Ian was talking about earlier, how it's inside.
Oh, wait. Oh, actually, here we go. I did the wrong thing. You're actually right. That would be it. I didn't want to do that. I had written it there, and I just forgot that I wasn't going to put it in there yet. We're not going to put it in there. This is how we write it. So I'm going to return number times factorial minus 1. Okay? So we're going to times it by, we're going to return the number, bloop, and then we're going to minus 1. So instead of doing this, as I kind of described we're doing, we're actually going to be doing something like this. 5 times 4 times 3 times 2 times 1, right? This is going to be the first number. That number gets returned. And then these numbers get stacked. Actually, no, I'm sorry. It is this. Because when we load them into the stack, one at a time, this will be the first function that gets loaded. And that will contain the number 5. And then this will get loaded into the stack the next time and the next time. So let's just take a look. So if we did this, I'm just going to console log just to make sure this thing works. Console.log factorial number 5, right? Let's see if it works. Oh, this thing seems to still be working. All right, num1. All right, so I'm going to save it. Let's run it and see what we get. What did I do here? I'll go at 10, return num.
Return is spelled
yeah.
wrong.
Return.
You need an R on return.
Yeah, okay. Console, boom, run it. That's it. It was blue, so it just kind of made it seem like it worked. All right, so we have 120. It works. What I'm going to do is this. I am going to go into, we'll add a debugger so we can see the process that's happening, right? So I'm going to say, let's add a debugger here. Okay, I'm going to add a debugger here. Now I'm going to save it. I'm going to run it. Takes us into debug mode, right? So here we go. Here we are. I see the call stack. The call stack says number 5 is, the number is 5, right? Because it's the first time this thing ran. Awesome. Okay, I'm going to step into it. Here, step into the function using this. I'm going to go into it. I'm in the if statement now. All right, if number is 1. We know that that's not true, so it's going to jump to the else. Boom, it jumps into the else. And now we are going to return this. Now watch. It's going to load another function called factorial. Boom. Look, here's the other function. So the first function is the number 5. The next function that gets executed contains the number 4. Okay? I'm going to do it again. The if statement is not true, so it jumps to the recursion. Cool. Watch, it's going to stack another one here. Boom. And that one contains the number 3. Okay? So what I want you to see is, originally, this factorial right here has the number 5. That's this version of the function right here, number 5. This factorial here has the number 4. That's this. This factorial has the number 3. That is this one. Okay? So as we're stacking it, it's 5, 4, 3. If we do this again, 2, 1. So now this is 1. So this is the order of operations now, because as we pop this function off, it's going to return the number 1. Then it's going to take 1 times whatever returns from this is 2. That'll be 6. That'll be 2. And then it'll take 2 and times it by whatever number is returned from this, which is the number 3, which will be 6, right? And then 6 will times by whatever number was returned by this factorial, which is 4, that'll be 24. And then it'll be 24 times the number that's returned from that, which is 5, and then we have 120. So watch as we go through this now. Okay, we're gonna see this happen. The next time I go through this, this function is gonna get popped off the stack. It's gonna disappear. All right, let's go. It is 1, so it's gonna return the number 1. Here it is, the number 1. It's going to return it. Boom. It's returned it. Now we just lost one of the functions, right? This one has a return value of 2 now. Our number is 2. I'm going to do it again. Boom. Do you see how it's stuck in here now? It's just returning the function calls, right? Because we're inside those functions, inside that memory space that's like, this is where we left off. We had to let these other things run. And when you finally come back to me, I will then execute the thing that you asked me to execute, right? Or return the thing that you asked me to execute here. So the return value is 6. Awesome. We're at the number 3. Okay, so remember, 2 times 3 is 6. the return value is 6. The return value of 2 times 3 is going to be 6. Boom. All right. The return value is 24. Okay. So this number here would have been 4, right? 4 times 6, right? Keep going. Return value is 25. We're back now to the base function, the original function. The original function where the number that we gave it was 5, but now the return value is 120. And if we terminate it, bloop, function's over. Okay, scope is wiped out. There's nothing there. There's only I. See, only because originally we had I. So now I see in the scope there's not in the scope, but in the script we have an I variable there that we can use. We're not using it though. Okay. So what you're seeing here is that what I really just kind of want to convey with this, right? And without you working through problems on your own, you're going to struggle trying to like work out solutions. Okay. So what you want to do when you first approach this, when you first approach creating these recursive functions, determine what is the base case. Just ask yourself, how can I stop the function from running? That's the good starting point. What do I need to do to like stop this thing from a perpetual loop? Okay. And so we did. We said if number was 1, equal to 1, return 1, that would stop it. Okay. After you've determined the base case, determine what is the recursive case. Okay, what do you need to do? Why is the function calling itself? Why is it doing that? Okay, and the reason here is this is why the function's calling itself. So it can times a number times whatever number would ultimately be returned from that. Okay, it's really this. This is what it kind of looks like in memory space. Like this. It's kind of similar to this. I'm not going to run it like this, but I'm just trying to visualize it for you. Like this function returns and returns a number. This function returns one less than the previous number. This one returns one less than the previous number. And then this number is the only number left, right? Because it's going to return 1 at some point in time. This is what it looks like in comparison to what we were doing down here. Okay? So really, this is num, or 1. This gets returned as 1. And then these individual ones are the return result of these functions running and running and running again. Okay? So visually, this is what it looks like. I'm not going to leave it like that because that's not going to work, right? That's going to break the code. That's going to do something completely different than what we want. I'm going to leave it like that. Cool? I don't know. Does that help? Does that make it any clearer at all? Or is it just...
I guess what happens, like what I have trouble understanding is that like it's just storing the values each time it runs. So it's stores 5, 4, 3, 2, 1, but it doesn't multiply them all out until like the end.
Correct.
But the way the code looks, it looks like it would be multiplying and getting that value each time it runs.
Yes, it does.
So like the first time it runs, it would be 1 times 0, or I don't know. But as you go along, it'd be 1 times 2.
Sure.
You would save that value in the memory. And
Correct.
Then, I don't know. It's just, that part is weird to me.
You know what? Think of it like this. So say if I had some files here, right? So let's just say ls. I got some files here. I'm going to make a folder. mkd, here we go. mkdir deletes me. Okay, sweet, delete me. Now, if I go into delete me, change the right reason to delete me, and I create a file, if I touch, delete.js, cool, I have this file. If I go back up the chain and I say remove, delete me, is it going to remove that folder? Anyone know what happens here? Does it remove the folder? All right, so let's take a look. It can't, rm is for remove, right? It's a Linux command to remove. And it says it can't remove that file because it's a directory and it has something inside of it. So if I do this, it still has delete me right here. It won't delete it. But if I do this, if I do rm-rf, this R right here stands for recursion. Recursively go into the folder structure and find the last folder and the file that's in there, delete the file, then delete the folder. Because if there was no file in there, I could delete it. And F is to force it. So now if I do delete me, it deletes it. It's not there anymore, right? So once again, if I do a mkdir and I said delete me, I'll just do this one more time. Delete me, delete, right? I misspelled the E, but I'm going to remove it now. Delete, and it won't do it. You need the RF here. It won't allow you to delete something that is a directory. You have to use the recursive. It needs to go into it to make sure it's empty to delete the things that are out of it. But just think you wanted to delete a top-level folder that had 1,000 folders, that inside of it had files and folders, that inside of those folders had files and folders, right? This recursion here would go all the way down the whole tree structure to the very last folders that it could find in any given path, delete the files, and then delete the folder. And then move up, delete the files, delete the folder. Okay, so think of it just like a tree with branches that just goes out in all directions and then it works its way back up. Okay? That's kind of what we're trying to do here with this factorial. Like execute functions, stack them on top of each other, and then finish running this one. When we hit the last one, it returns a value and then we can go back. So recursion is going to the very end and working your way back. That's what recursion means. You do what you need to do and keep doing it till you get to the very end, to the base case, and then you work your way back towards the beginning, okay? Any other questions?
Joe, in the General Assembly PowerPoint or whatever it's called, they talked about a third step, the action step, that's in between the base and the recursive.
Yes. You could have that. Now, once again, you don't always need to have something like that. So in this instance, we're not really doing this, that particular action step. You don't, it's not always needed. You can wrap up that kind of action step inside of the factorial. Like inside of the recursive case, you can wrap it up if you need to. It doesn't always have to be outside of it. I've always just explained it as like base case and recursive case, because when I'm doing the functions, it's either stop the function or have it do this thing. That's usually what it is. But sometimes, say if we wanted to find the max number in an array, I might have to have some other logic running, which would be the logic you're just talking about. And then I'd have to rerun the find max function again to do something else. So we can walk through that. I can't do that problem right now. We just don't have time, but maybe the next time we hit recursion, I can kind of walk through another scenario. I wanted to keep this one simpler.
Well, Joe, my question was going to be, is the action step the part where we are digging for that very last number?
You mean this one? Oh, the action step? Oh, the step between the base case and the recursive case where we're looking for that number, right?
Like we haven't hit the base yet. We called the function.
Sure.
And we're storing these numbers. Like, is that where the call stack exists in that action?
I would say something more like this. If I was summing an array of numbers, I would want to find, if I had an array of numbers and I wanted to get the total sum of those numbers, just think it through, right? If I'm going to remove numbers from the array, then my base case would be something like when the array length is 1, then I just have one number, right? That's my base case. The recursive case is to pop out a number out of the array, right? So ultimately, I have to have an array that has one element in it, and the recursive case would be to pop out a number, right? Where does the sum happen? Where does the adding those numbers together happen? Here's the recursive, here's the base case, array is equal to 1 in length. Here's the recursive case where I pop a number out of the array. Where do I actually add the numbers together? Where do I do sum is plus equal to the current element in the array? Well, that could go right in this middle, that action step. That action step could be like, all right, it's not the base case, so there must be numbers. So grab the number, grab the last number in the array, add it to some sum, and then pass the array down. And then this recursive case will pop a number out of the array, push it back in. If it doesn't meet the base case, then do the whole sum thing again, then pass it back to the function, and we'll rip it out and we'll do it again. So the action step would have been that middle section where you would have added the numbers together. But sometimes those numbers can be added doing something like that as well, okay? Sometimes you can do this. You can kind of combine the action step with the recursive case. I don't know if that clears it up. All right. Puzzled looks. Puzzled stares and looks. All right.
In the base case, why do we need to return a value? If the ultimate objective is just end the function there, can we just leave it as return? Like, why do we need to return 1?
Oh, because 1 is the last number in this sequence of numbers that we want to start this multiplication process, right? I want to return something here to stop the function, and then once I return 1, I can then use 1 here. This base case becomes this number right here. That's the base case is the last function in the call stack. It returns the number 1, and then we use the return value there to start the process. 1 times the previous one, which would have been 2. We times those together, that's 2. Then 2 times the previous function call that returned 3, and then we times that, okay? So this number here, just know that this number is the last function call that we want there, okay? Just like when we did this, when we did the reverse a string, we returned an empty string, and we returned an empty string so we could start concatenating something. There was an empty string, and then we can add a letter to the empty string, and it would be like, oh, I'm just going to take the place. You're a string, and I'm just going to kind of add myself. There was nothing before you, so I must be the first letter in this empty string. That makes sense, Matt? All right. Cool. Any other questions? We got to jump in. You see Thad's shaking his head. Aaron's just like, Josh is just like,
I'm not feeling too hot anyway.
What's that?
I said I'm not feeling too hot anyway, so this is kind of like a double dose.
I gotcha. Okay.
Joe, I made you a Joe-moji finally.
You did?
Yep.
Let me see. Did you post it yet?
I'll put it in here.
I don't think anyone's done that. Thank you. There we That's my good side too, Jeremy. My good side. It's my handsome side. All right. No more questions. Then I'm going to pass it on to Matt to jump into the lectures. I'll add this code pen. I'll add it to this morning's lecture, and I'll just put a link there, and I'll add the code that we did also. So you can look at the code. You can go back to the code pens, whatever it is that you want to do. Cool? Sweet. All right. I'm going to stop sharing.